Okay, for this homework, this last homework of the semester, and to get you ready for the final, I'd like you to copy down the problems I'm showing you here, and then I'd like you to make up for each one your own problem. I'm going to give you the example, the first one, but then after that, you're kind of on your own. Be happy to help you tomorrow in class or when I see you. But again, write down these problems, and then for each one, make up your own problem with your own numbers. All right, good luck. And of course, listen over the secret words to make sure you are listening from beginning to end. Show me those words for full credit. So here we go. This first page. Again, this first one is just plugging in number of days and then using your calculator to watch your arithmetic and do the math. 35 plus 17 times 8. Be careful not to times 35 times 8. 17 times 8. Use my calculator, gives me 35 plus, this one's going to be 136 plus that 35. If I add those two up, that gives me, after 8 days, I've spent $171. Days is my independent variable. Cost is my dependent variable. Independent, my x value, my days. Y value, my cost. An example you can make up could be the number of days that you plug in gives you the cost. So 39 plus 16 days, there's an example of an equation. So maybe after 4 days, how much you would pay. 4 would be the number you plug in right here. When you plug in 4 here and do the math, that gives you the cost. X-axis would be number of days which you control over. Plug it in, gives you the cost, the y value, or the f of x value. I'm just showing some math right here if you were to use this equation as yours that you're made up. So here we go. There's the first one for you. Here's an example of one just like it with different numbers. First word, of course, is blue. Blue. For this one, I want you to graph it. First one has a y-intercept of -3. That rate of change, or the common difference, or the number I'm adding each time in the sequence, 2 over 1 up 2 over 1 up 2 over 1 up 2. My red line, y-intercept of +5 with a slope or rate of change of -2 over 1. So +5 over 1 down 2 over 1 down 2 over 1 down 2. That is the rate of change for that red line. And you can see that when they go over 1 down 2, they intersect clearly at this point. 2 for x, 1 for y. Make sure you clearly label that coordinate. And then, of course, a little hint to help you out. If you do a little vertical shift, if you just shift these lines, I'm going to move this one down, move this one up, or maybe move it around. Do a little shift. See if that will help you get equations that will intersect. Just a little hint, I'm not sure. All right, next one. This one says distribute, or it shows me clearly I'm distributing, and then I want you to label that. So if you could write this problem right here, this is the given equation. This is going to be step 4, step 3, step 2, step 1 in colors. Sorry about that. But I clearly see my first step, I'm distributing -3/5 times 10x. That when I go straight across gives me -30x over 5, which is -6x. Or I could have got that by cross canceling 5 and 10 to make that 2, and then 2 times -3. But either way, that is the distributive property. I am then combining 14x and -6x to get that 8x. That is combining like terms. After that, I'm taking away 12 on both sides. Inverse operation, -12 on both sides. And that is the subtraction property. And then my last step, I am and I'm not sure why I wrote minus 8x. I subtracted 12 on both sides. Divide by 8. Divide by 8 is the division property last to get that x equals 2. So pretty easy. First step, distributed, combine like terms, did an inverse operation, subtract 12 on both sides, and then divided. You could change it up a little bit if you want. Alright, second word is surf. For number 5, remember this one is the free problem, but I'd like you, for math's sake, to show me the math where I'm substituting one piece into the other to get the x value. So plug this in. So where that g of x used to be, I'm going to substitute that with negative 2x plus 8 equal to 7x minus 1. Show me you could solve this variables on both sides. Take away that 8 on both sides. Bring down the negative 2x. Bring down the 7x minus 9. Take away 7x on both sides. That gives me negative 9x equals negative 9. Divide both sides by negative 9, and that gives me x equals 1. So I want you to see that with that x being 1, if I took that and substituted it in or evaluated for one of those, that would give me the y value, or the f of x, or the g of x value. So if I plug it into f of x here, plug that 1 right where x is, negative 2 times 1 plus 8, that gives me negative 2 plus 8. So the function at 1 for f of x is 6. And I can clearly see if I plugged in 1 here for the g of x, I would also get 6. So that's the point that they share in common, the intersecting coordinate. But again, this is a free problem, skip it. On number 4. I'm sorry, this is number 4. For this one, again, cars is $17 during peak, $3.50 less. Buses, 14 peak and off peak. These top two values, I'm going to put peak cost, bottom two off peak. So you could see for cars, peak value 17, 350 less, 1350 is off peak hours. Buses 14, off peak hours 14. So again, filling out this table where the top two values are peak hour prices, bottom two for cars and buses, off peak hours. For this next one, I want you to clearly see this is a function, and again I'll show you why. This next one is also a function. X's do not repeat. This table is not a function. I have two x values giving me the same y values, can't have that. And then this input-output diagram, violating the function principle. It has an input spitting out two different output values, cannot have that. So for this, select 2, only those two. I changed that up a little bit. Third word is break. Break. Alright, number 7, this one. Find the inventory set, which is clearly this 35, 30, 40, 37. For the next one, find the rate of change, 343 cookies per 7 hours. Make sure you're showing me that unit rate, 343 cookies made for every 7 hours. And if I divide that, that gives me 49. The number of the day, which equals 49 cookies for every 1 hour you're baking. So of course that cookies for every 1 hour unit is written as cookies per hour. Cookies divided by every hour. Per hour. Which would be cookies per hour. Alright, plugging in -9, following the math. Gives me 6 times -9. Make sure again you're using your calculator to do your arithmetic. So that gives me 6 times -9 minus 7, which gives me negative 54 minus 7, which gives me negative 61. And again, the number I plug in, that negative 9, will represent my independent variable. My number I spit out is my dependent variable. All right, next problem. I changed this up a little bit. I want you to make this equation negative 10x plus 12. So if I plug in 0.5 into that x spot, that gives me the function for this one I'm giving you is the function at 0.5 equals negative 10 times 0.5, which of course is half of negative 10, which gives me negative 5 plus 12, which I can see is 7. So when I plug in negative 5, half of negative 10 is negative 5, plus 12 is 7. I circled the 7 for this pull down. I want you to see that that number I plug in is time, half an hour. What gets spit out is distance. So again, to fill out this statement, the function for f when I plugged in 0.5 gave me or equals 7, and that 7 represents the distance number when I plugged in 0.5. And of course the 0.5 is the number I plugged in when she was walking for 0.5 hours. So remember, again, this would be time, my x value, my independent variable, my y value, f of x value would be my distance. I control my time. When I plug it in, the equation spits out distance. So distance is a function of time, or distance depends on time. So again, know that principle. All right, this problem right here, remember it's weird for this. I'm pretty sure they're talking about this situation where you have two places where these functions intersect. These are neither linear, I'm not sure what kind of functions they are, but you can see that as you're going down through the x-axis, one value is higher than the other, and then you'll get a switch where then the other value is higher. That's a point where they are the same, and then that will be lower, 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 and then you'll have a switch back where that other one goes higher. So this would be f of x higher, g of x lower, f of x higher, g of x lower, then switch. F of x lower, g of x higher, f of x lower, g of x higher, f of x lower, g of x higher, then switch. F of x higher, g of x lower, f of x higher. So again, they're showing that relationship here where the f of x value is lower, then the next step down it's still lower, it's still lower, and then all of a sudden right here, switch. Now it's higher. That zone right there is the first interval where it starts to intersect. And then you can see higher, f of x is higher. F of x right here is still higher. And all of a sudden switch. Now f of x right here is lower. Those two boundaries show right here where they start to overlap and intersect. For me to try to make one up would be f of x lower, f of x lower, and all of a sudden switch. Now right here, the f of x value is higher. It used to be f of x lower than g of x, f of x lower, and all of a sudden switch. Now f of x is higher. So that interval right here, boundary -2, -1, and then keep going. F of x higher than g of x, hopefully. And again, that is the boundary. F of x higher than g of x. F of x is higher than the g of x number. F of x is higher than the g of x. Oh, and then switch right here. Now f of x is lower. And again, that boundary where it switches marks the boundary where they intersect. So trying to explain this again. The f of x1 is lower, still lower, and then switch. Now it's higher. That's the boundary. F of x value is higher. All of a sudden right here, switch right lower. So right away I had a boundary switch. For this answer, -1 to 0, 2 to 3. For mine would be -2, -1, 0, 2. So if you could on your paper write these, the red one here, the boundary -1, 0, 2, 3, and my boundary -2, -1, 0, 1 to try to show their reasoning to that problem. Number 12. To find 3a, I just take matrix A and times everything in there by 3. Distributing 3 all the way through. 3 times 6, 3 times through, 3 times -3, 3 times 4 gives me 18, 6, -9, and 12. 18, 6, -9, 12. Timesing everything in matrix A by 3. If I add the values of matrix A and B, I'm just adding those values to get my next matrix values. So 6, 2, -3, 4. The next word is set. Set. Alright, so back to this. 6, 2, -3, 4, 0, -4, 2, 6. Add those up. Gives me 6 plus 0, 0, 6. 2, -4, -2, -3, 2, -1, 4, 6, 10. So that would be when I add the sum of matrix A and matrix B. The harder one, when I times these two, I'm going to take matrix B times matrix C in that exact order. So make sure I'm listing matrix B first, 0, -4, 2, 6, times matrix C, list that second. Don't flip that around. I'm taking this first row times this first column to get my first value. So I'm doing 0 times -3. Remember, that's not -3. That's not anything. 0 times -3. Don't make that mistake I did. Fix that. 0 times -3 is 0. -4 times 0 is 0. Next, 0 times 2 is 0. Switch down. -4 times -6 plus 24. Next, this 2, 6 row. If I take 2, 6 times -3, 0. 2 times -3 is -6. 6 times 0 is 0. Take that bottom row times this last column. 2 times 2 is 4. 6 times -6 is -36. Add those up. Gives me the product BC is 0, 24, -6, -32 for this problem right here. So there we go. There's 0, 24, -6, -32. Alright, this one's solving this inequality. Piece of cake. Add 8 to both sides. Bring down my -2x. Bring down my inequality. Gives me -2x less than 28. To make this more complicated, the opposite of timesing my -2 dividing by -2 makes my inequality switch direction. This used to be negative over here, but now when I divide by -2, now it's positive. This side used to be positive, but now when I divide by -2, it switches to negative. Have to flip the inequality to keep this statement true. That would be a open circle on -4 more than all the numbers to the right of -4. And again, if I wrote that in interval notation, rounded bracket on that -4, comma, infinity rounded bracket, set notation would be -4 less than x less than infinity. Alright, for this graph it using the y-intercept, +4. Use that rate of change or the common difference, -4/5. Right 5 boxes, down 4 boxes. Right 5 boxes, down 4 boxes. I can clearly see I get my y-intercept right away, and then with that one step, I get my x-intercept. I need you to memorize that. For the x-intercept, no matter where it crosses the x-axis, the y-coordinate always 0. 5, 0, 4, 0, all these. For the x-intercept, I want you to memorize that. For the x-intercept, the x value is always 0. So think opposites. Y-intercept, x is 0. X-intercept, y is 0. Memorize that. Next word is cloud. All right, keep going here. 15. 15, we want you to match them in there. So I can see that this says increasing -4 to -4. This has no -4, does not apply, but this one, -4 to 4, I could see it's flat. So it's neither decreasing nor increasing, maintaining the same rate. That one does not apply. Next one, increasing going up from -7 to -4. I could see that one applies to graph A, so I'm going to put a 2 in here. Decreasing from 4 to 22, there's no 22 on here, does not apply. Decreasing going down left to right from 4 to 22, so I'm going to put a 3 in box B. Next, decreasing from 4 to 9. So if I look at graph A, I can see clearly from 4 on the x-axis to 9 on the x-axis, it is going down from left to right. So I put a 4 in box A. And then increasing 4 does not apply. This is going down. So 1 and 5 did not apply to either. All right, 16, complex equation. I'm going to have you distribute. Combine like terms, solve variables both sides. -4 times 3x is -12x plus 2x equals -8x plus 6. Sorry about that extra equal right there. I would not write that. I'm going to combine these two terms, and again, erase that triple equal. -12x, 2x gives me -10x plus 8. And then clearly variables on both sides, I want you to recognize that. We want you to start by getting rid of the 8 on the left and then getting rid of this -8x on the right by adding 8x and then divide. Start on the left. Get rid of the plain number on the left. So that 8. Do the opposite, -8. Do the same over here. These cancel away. Bring down -10x. Bring down your equal. Bring down -8x. 6 minus 8 is -2. Stay on this side. Add 8x plus 8x plus 8x gives me -2x equal to -2. Divide both sides by -2, and that gives me x equals +1. Next word is whale. Whale. Okay, for these, to see which applies, see and focus on the inputs, your x's. As soon as you see any inputs repeat and have a different right away, as soon as you see these repeat, going to be bad. The next one, none of these input numbers repeat. Does not matter that all the outputs are the same. As long as these inputs are all different, that's golden. For the next set, I have a 4, give me a 1, a 4, give me a 3. That's a double coordinate. Cannot have a 4, give you a 1 or a 3. No good. Next set, none of these repeat as inputs. Good. Next set, I have an input, give me a 3. Another same input, 9, give me a 4. Cannot have that. So only these two sets. All right, next problem. I changed this up a little bit and made this rounded to positive infinity, so this would be a open circle on a graph. So I could see this one starts at 2 on the y on the right, no good. This one solid, no good. This one open on 2 on the x-axis, going to the right, that one applies. This one, even though it's going to positive infinity, has a closed circle does not apply. This one, open circle on that left boundary 2, it is going to the right in terms of left or right component. That is positive infinity. That one applies. And then this one is no good. Looks like from rounded 6 to negative infinity. All right, for this, the domain are my x values I plug in. What I get spit out are my y values, are my range. So all the x values for this data, 1, 2, 3, 4. The y values for this data, 20, 40, 70, 100. The next problem, and then for this data though, for this data, the x value would be 1, the y value would be this. So I can see my range goes from 1 to 4. X would be more than 1, less than 4. But my range spans from 20 to 100. So from 20 to 100 is my range. All right, for this next one, solve for g. Take away that 42. Bring down p minus 42 equals 6g. Divide both sides by 6. Divide by 6. Divide by 6. And that gives me p minus 6. And if I divide negative 42 and 6, gives me negative 7. So again, these two numbers give me that negative 7 number right here. P over 6, I leave p divided by 6. So that answer is g is p divided by 6 minus 7 equals g. Or if you want to flip it around, g equals p over, there you go, p over 6 minus 7. Okay, next problem. Again, do the math and then check the step. So if I distribute this, take that 3 times 5a minus 2, distribute, it says distribute, so that matches the correct math. Correct. Next step, take away 12a minus 12a on both sides. If it matches that subtraction I did, minus 12a, that is correct. Next step, adding 6, but on this side, subtracting 6. The math I did does not match this property. Incorrect. And then my last one, dividing by 3 to get that 2, but this does not say division. That would be incorrect. If it would have said division right there, it would have been correct, but does not say that. It says subtraction. Incorrect. All right, 22, almost done. Next word is point. All right, for this one, the minimum lowest is 1, 2, 3, 4, 5. So 5, negative 4. Clearly that is the lowest. My highest is over 1 up 4, my maximum. So minimum 5, negative 2, that's close, but does not apply. 1, negative 4, looks like a little trying to trick you with negative 4, does not apply. 1, 4, maximum, yes. And then maximum negative 4, 2 does not apply. For this one, increasing functions, they break it up. I could see that this first stretch, it's going up right here, is bordered from negative 5 to negative 4. Left to right through the x-axis, negative 5 to negative 4. First interval. And then from this negative 4 to positive 1, be careful, negative 4 to positive 1, don't fall for that one. 24, this would be from going down from positive 1 to 2. I could see border left to right through the x-axis going down 1 to 2. And then my other border from 4 to positive 5 going down right there. I can see another interval going down. So 4 to 5. Be careful for those distractors, those close answers. Okay, almost done. 25. Remember, that stretch is going straight. Don't say increasing, decreasing for that flat stretch. Okay, for this graph, the way I have it here, I have this at -6, -1. So I can clearly see 1, 2, 3, 4, 5, 6. That interval is at square bracket -6. Going to the right, even though this arrow is going down, that is a component left or right. So square bracket -6, left boundary to positive infinity. That is my domain. My range, because this one has no bottom to it, would be a negative infinity range measured bottom to top. This is going down. So negative infinity rounded up to this square bracket component right here at 4 where the data is included. So that would match this negative infinity 4. Be careful for the distractor answers, bad answers. Be careful. Close but negative infinity, close, rounded, close but rounded, close, wrong sign on infinity. Be careful. Alright, 27. Easy peasy. If it's dots, it's discrete. No dots, continuous. This graph definitely dots, discrete. It is going up from left to right, increasing. And this curve pattern is definitely geometric or exponential. If it's straight line or dots going through the line, continuous. This is going down from left to right, decreasing. And then this is definitely a straight line. If you want to use this as one of your made-up problems for this, feel free. Alright, last graded assignment. This is due the day of the final. Good luck.